Most people think of music as more of an art than a science. Although sound is a wave, and can therefore be described by the laws of physics, understanding how certain patterns of sound waves create what we perceive as music requires a much higher level perspective than merely understanding the properties of waves. Despite the complexity of music, recent research has shown that music can be analyzed using some of the same physics models commonly used to describe more traditional physics concepts. More evidence of this ability to describe music with physics comes from a new paper published in EPL by Gunnar A. Niklason, an engineering professor at Uppsala University, Sweden, and Maria H. Niklason, a musician at the Beatle Music Institute in Bromma, Sweden. The researchers found that the distribution of melodic intervals in 2 classical concertos and 2 folk songs can be modeled by a Levy distribution. They explain that melodic intervals are the pitch intervals between successive time intervals, which are defined by the duration of the shortest note, so each note may be equal to one or more of these time intervals. A pitch interval can also be roughly thought of as how far apart 2 notes are on a piano. The Levy distribution describes many other diverse scenarios, such as the turbulent motion of a particle in a liquid or gas, the changes in the price of a stock, earthquake activity, and the foraging paths of wild animals. Our work indicates a consonance between patterns in music and in nature, but how to interpret this is more of a philosophical question, Gunnar Niklason told physical.org. All Levy motions are characterized by a mix of many short and a few long steps, and also exhibit fractal properties. For a musical melody, this basically means that there are many small intervals, just 1 or 2 notes apart, and fewer large intervals, sometimes up to 20 notes apart, and that the numbers of these intervals are distributed in the shape of a sharp peak with long tails on both sides. Previous research has implicitly assumed that melodic intervals follow a Gaussian distribution, i.e., a bell curve, but a Levy distribution is different from a Gaussian one, so the new results challenge these assumptions.